Morning campers, I've had a request from Katie who wants me to cover the solution of exercise 5.1 question 1 in module MA2500. So omega denotes a sample space, curly F denotes a sigma field over the sample space, and we have this function x which is the indicator function of the event A. And the challenge is to show that this function really is a random variable over the pair omega curly F. And what this means is that we have to show that for every Borel subset of the real line, that these events, consisting of all those outcomes that are mapped by x into the set B, is an element of the sigma field over omega. So let's give it a go. So let's start by defining B to be a Borel set. And we have to consider four cases. So the first case is that 0 and 1 are not contained in the set B. Then the sets that are of interest, well, which outcomes are mapped by x into the set B? Well, x only maps outcomes to the value 0 or 1. These are not contained in B, so this is the empty set, and of course, by definition, that's contained in F. So case 2 is perhaps that 0 is an element of B, and 1 is not an element of B. Then the event of interest here, all those outcomes that are mapped by x into the set B, well, they will be the outcomes that line A complement, because they're mapped to 0, which is contained in B. Outcomes in A, which yield the value 1, is not contained in B, so this is A complement. Okay, well, we know that A is in F because it's been given in the question as an event, so A complement is also in the field. So case 3, let's now consider the case where B does not contain 0, but where it does contain 1. Okay, then those outcomes that are mapped by x into B this time, well, all outcomes that lie in A are mapped to 1, which is contained in B, and all outcomes that are mapped to 0 are those in A complement, which is not contained in B, so this is just the event A, and that's in F. And the final case is when 0 and 1 are both contained in B. So in this case, the outcomes that are mapped into the set B, well, that includes all outcomes, because all outcomes are either mapped to 0 or 1. So this is the full sample space, and that's also contained in F. So in all four cases, we've shown that these sets are contained in the sigma field, and we're done. So if we move on to part B of the question, part B says that A1, A2 up to AN, which are events contained in the field, that these form a partition of the sample space, and that little a1, little a2, little an, these are real numbers. And we have another function now, x, which is defined really to be the linear combination of the indicator functions of the events a1, a2 up to an. So part A established that the indicator function of an event is a random variable. And now we're going to try and show that a simple function, these are called in general simple functions, that these are also random variables according to the definition given. Okay, so as before, let's take a set B from the Borel field, so a Borel subset of the real line. And what we need to show is, as before, that the events consisting of those outcomes that are mapped by X into the set B is an element of the underlying sigma field. The thing to notice here is that for all outcomes contained in AI, X applied to that outcome takes the value AI, little ai. So, if this value lies in the set B, then all of these outcomes, all of those contained in AI, belongs to this set here. While of course, if this value, little ai, is not contained in B, then all of the outcomes in the associated event, big A sub I, is not contained in this set here. So we can write this event here then as, okay, those outcomes that are mapped by X into the set B is the union of all those sets A sub I for which the associated value belongs to B. And this is an element of curly F because curly F is closed under finite unions, something that we proved way back during the first week. So to conclude, we've shown that events of this form lie in the field, and this is for any Borel set, and therefore by definition the function here is a random variable, and that concludes the solution to part B. So that's it. Keep your requests coming in, but for the time being, goodbye.